Okay, so this is problem 2 from the second exam. So we're told that f is a differentiable invertible function, and we're given some values of this function in this table, which I've reproduced. And the first thing we're asked to do is find the value of f inverse, its derivative, at x equals 3. And so we have a formula for the derivative of an inverse function at a given point, which is that it's 1 over f prime of f inverse of that value. So if we look at the table, we can find the value of f inverse of 3 because we see that when f is equal to 3, x is equal to 2. So therefore, f inverse of 3 is equal to 2. So therefore, this value that we're trying to find is going to be equal to 1 over f prime of 2. So that's from evaluating this inner part here. And then if we look at f prime when x is equal to 2, that's also equal to 2, so the derivative is 1/2. Now for the second part, we're asked how do we know that the inverse function is well defined when x is equal to 4. So this is by the intermediate value theorem essentially, so that we see that when x is equal to 2, f is equal to 3. When x is equal to 3, f is equal to 5. So somewhere between 2 and 3, f must have been equal to 4. And at that point, we know that f of x equals 4. That means f inverse of 4 is equal to that value of x. So to sort of argue this rigorously, we first need to know that the intermediate value theorem applies. We need to know that f of x is continuous. So since f of x, we're told, is differentiable, that means it is continuous. And we know that f of 2 is equal to 3, which is less than 4, and f of 3 is equal to 5, which is greater than 4. So f of x is equal to 4 for some x in the interval from 2 to 3 by the intermediate value theorem. And therefore, f inverse of 4 is equal to x for that value of x. So a lot of people had the right sort of ideas, but not quite organized in the right way. So you really need all of these pieces of information in order to conclude that the inverse function is well defined at 4. And since we know the inverse function is well defined at 4, we can try to estimate its value using the information given in the table. That's what we try to do in part C. So we do a linear approximation. F inverse of x is approximately equal to f inverse of 3 plus the derivative from part A evaluated at 3 times x minus 3. So this is the formula for a linear approximation. And then if we plug in all the information we have, f inverse of 3 was equal to 2. The derivative of f inverse at 3 was equal to 1/2. Then we have an x minus 3. And this can be simplified to 1/2 x plus 1/2. So using this approximation, f inverse of 4 is going to be approximately equal to 1/2 times 4 plus 1/2, which works out to be 5 divided by 2. So that's how you would approach this problem.